So we've covered simultaneous equations, where we have learned about the methods of solving simultaneous equations. Now let's deal with some worded problems, because in math, of course, we can show you that it applies to almost any real life scenario. So these are where our worded problems come in. So if you looked at how we solve simultaneous equations using both methods, and you think you're ready to handle some worded problems, let's get straight into it. Alright, so by the time you're finished with this session, you should be able to create algebraic statements, whether they be expressions or even equations, to represent information about a given scenario from worded statements. And then you want to be able to apply an appropriate method to solve a system of linear equations to obtain the solutions to the problem. And we have discussed these methods. So if you want to just go back over those methods, if you haven't seen those videos on the methods of solving simultaneous equations, those videos will be linked in the cards, so you can click on them and just go check them out if you want to before you jump into today's video. But other than that, if you want to feel a little bit clear about what you're doing in today's lesson, pay attention to the areas of pre-knowledge that have outlined below, and if you feel like there's anything you need to brush up on before you jump straight into today's lesson, go find yourself some content and refresh your memory. So, because we're dealing with algebra still, you want to make sure that you're comfortable to do simplifying algebraic expressions, inclusive of those with distributive law, because there are times when you're going to come across some problems where we have some brackets involved. You also want to make sure you're confident in your abilities to do substitution, because we know one of our techniques involves the process of substitution, and even when we have to solve using the elimination method as well, we've used a bit of substitution. So it's going to be extremely important that you know how to do substitution. Other than that, you want to make sure you can solve linear equations. I mean, after all, you are solving equations, simultaneous equations, and go over those methods if you don't remember them, and if you can't even remember the processes when you have to apply each method. And definitely, operations on integers is a must for anything algebra. So if you feel like you're comfortable with those areas, we're going to jump straight into today's video. We're going to look at a worded problem and see how we can apply our techniques to solve this particular scenario. So let's jump straight into it. So these questions, all of the questions, as a matter of fact, all of the problems that I've looked at come from CSEC past papers. Trust me, when you're browsing, I mean, if you dig far enough, you're going to find some of the questions that I use. But let's get started. So the one that I found that we're going to be using is based on these items here, right? So they say candy store packages lollipops and toffees in bags for sale. So they give us these images here, although they would have said it as well in the worded statements, but I'm just working with the images, right? So they're telling us that the mass of one lollipop is X grams. They don't know what is the mass exactly, so it's unknown, it's labeled X. And they also have toffees, and its mass is Y grams. Again, something that's not known, so it's labeled with a variable. But the scenario basically is going to be based on these two items and their masses. So what they've told us in the information provided in the question is this. They said that 5 lollipops and 12 toffees have a mass of 61 grams. So how do they know that? Remember, we said they're packaging these items into bags for sale. So they're probably putting together the items and then dropping it on a scale to estimate its mass. Whatever reason, alright? So that's the one scenario. They put 5 lollipops and 12 toffees together. Its mass is 61 grams. And then in another case, they put together 10 lollipops and 13 toffees, and that had a mass of 89 grams. Okay, we want to write two equations in terms of x and y to represent the information above. So where do x and y come from? Well, x and y come from the masses of each individual item, as I've mentioned earlier. And what we're going to do is take the information they've given us about each bag to create an equation in terms of x and y for the overall mass of each bag. So the first bag is going to create one equation, and the second bag is going to create another equation, because each bag contains each of these items, right? So the bags all have different quantities of each item. So what we are attempting to do with creating these equations is attempting to create these statements to work together so that we have a system of linear equations that we can use to find these unknown masses. Alright, so that's essentially the general idea behind what we're doing. So the first thing, of course, is always to write the equations. So anytime you encounter a worded problem, the first thing you should want to do is analyze your information and see what information is provided about the scenario that you can use to create an equation. And in a case of simultaneous equations, obviously you're going to create two equations. You will also have two unknowns, and we already have identified our two unknowns, so it's just to put the information together to come up with these equations. Now, the first bag, as I said, is going to create one of our equations, which tells me that the mass of the items altogether have to be 61 grams. So if the first bag contains 5 lollipops, then the mass of the 5 lollipops would be 5 times x. So I'm going to start off by writing down 5 times x as the total mass for the 5 lollipops in that bag. Now, it's not just 5 lollipops in the bag, it's also 12 toffees. So I have to add in the mass of these 12 toffees, and each toffee weighs y grams, so I'm multiplying 12 by y to get the total mass for the 12 toffees in the bag. So I'll write down 12y. Now remember, they all are placed in the same bag, so this means that we're adding 5x and 12y. This is basically an expression here for the total mass of all the items in the first bag. And the total mass of all the items in the first bag is equal to 61, because they told us that the mass of the first bag is 61 grams, right? With the 5 lollipops, 12 toffees, 61 grams. So our first equation, we're going to label it one time. This is our first equation. 5x plus 12y is equal to 61. Now, our next bag contains 10 lollipops and 13 toffees and have a mass of 89 grams. So if you've caught on to what we're doing with creating the equations, I'm sure you are able to construct the equation on your own. So you can try it out, and I'm going to do it alongside you right now so you can see if you're on the right track. So the mass of 10 lollipops, that's the first thing you need to put together, right? The mass of one lollipop is x, so 10 lollipops would be 10x. And then the mass of the 13 toffees would be 13 times y. And again, it's all together in one bag, so we add, and that totals up to a mass of 89 grams. So this is our second equation. Now, just in case you're asking, well, why do I have to put x and y in the equation? Why can't I just put 5 and 10 together because they're the same things? You can't do those things here, because essentially the scenario is outlining that each bag is containing different quantities of the same items. So we can't just lump it all together just because they're x's right now and just because they're y's. In a case like this, you have to put each equation containing x and y because of the fact that that's how they package the bags, right? Remember, the equation is really and truly modeling the information about one of the bags, well, each individual bag that we were told about. So you don't know the information about the total of the 15 lollipops together, for example. So you can't just take them all together and somehow miraculously come up with something that's going to give you the answer for X without having to go through this process. Alright? So I know sometimes in the mind of a student is like, okay, well, why do I have to go through this entire process? Is there some shortcut that I can do? No, there is no shortcut right now. You have no shortcut. You have to go through this route. So once you have your two equations, we can hop along to the next part, which obviously is going to be to solve the system. We want to get the answers for X and Y respectively. So the next part of the question is calculate the mass of one lollipop and one toffee. Okay, so I'm going to write back these two equations that we just constructed here, and then we're going to attempt to solve. So my equations are as follows. We had 5x plus 12y is equal to 61. And we had 10x plus 13y is 89. Okay, so if you've followed the series along the path of the introduction to simultaneous equations and the two methods, then you know that whenever we have to solve simultaneous equations, the first thing we need to look at would be the system and the variables that we need to solve for, and determine a variable that we, would want to work with. But it always starts with determining a method that's appropriate. Now, in both of my videos, I would have said when would be preferable to use one method over the other. And this is one of those cases where there's no choice but to use an elimination, simply because I would say if you try to use a substitution, making any of these variables a subject to any of the equations would make it such a cumbersome equation to work with when you have to do a substitution. And to avoid the headache of making a mistake when you have to do that process of substitution, it's better to opt for using elimination here. And you can choose which variable you want to solve for first. Now, they would have indicated that they want the mass of one lollipop and then the mass of one toffee. And you might feel compelled to try to solve for X first, which would mean that you'd have to eliminate Y first in a case like that. But you can solve your system to suit you and then write in your answers, right? So let's do the elimination process here. And in doing the elimination process, for me, the easier way is to bring my coefficients of X to the same value. So I'm seeing 5 and 10, and it's pretty easy for me to make the other term in X have a coefficient of 10 as well. I just need to multiply this equation by 2. So let's do that, right? We're going to multiply equation 1 by 2 to create a third equation, and then we're going to do our elimination process. So equation 1 by 2 would give me 10x plus 24y is equal to 122. Now remember, you have to multiply everything in the equation as well, right? Not just x. So this is the reason why we have this equation the way we do. Now let's proceed to do our elimination process. And what I'm going to do is I'm going to subtract equation 2 from equation 3. right? Now, there is no hard and fast rule saying that I can't subtract equation 2 from equation 3, but if I do that, I'm going to introduce negatives into the picture. So let's keep life nice and simple, and simply because I know I'm eliminating a variable x in particular, and I'm going to be doing subtraction, I would prefer to put the equation where the other terms in the equation happen to be larger, which is the case of equation 3, right? Put that one as the one first in my subtraction, so that way I don't necessarily have so many negatives to deal with, right? But you'd still get the same answer, it's just that you'd have to deal with negatives. So let's continue along. Like I said, I'm going to do equation 3 subtract equation 1. And if you're the type of person, you might find this a bit difficult to just follow along like that. You have to write it out in a way that you can see it. Feel free to write back equation 2 underneath the equation 3. Alright? That way you will be able to see it a little bit more easily when you're doing your subtraction, right? But if you're okay with just doing the subtraction because you know you have to subtract term in x from term in x and term in y from term in y, etc., you go ahead with the procedure just as I'm doing it. So again, as always, whenever you're working on problems in math, and there are different ways in which you could deal with the question, I always say it's best for you to work the solution in a way that you're comfortable with, because you have to be the one to go back over and check over your process and make sure you're doing the right thing. So I'm subtracting equation 3 from equation 2. I just had to fix that. And now I'm going to do the subtraction part of things. So I'm subtracting my terms in x, which would leave me with 0, so I don't have to worry about x. Now I'm moving on to my terms in y, and I'm subtracting 13 from 24. So 13 from 24 is going to leave me with 11. So I have 11y. So like I was saying, if you decided to do equation 3, take away equation 2, take away equation 3, you would end up with negative 11 instead, right? Now let's do the constants, and the constants are 122 take away 89. So 122 take away 89 would leave me with 33. And all I have to do from here now is solve for y by dividing both sides by 11. So this leaves me with y is equal to 3. So we'll come back to our solutions in a little bit, because remember, we're not just doing an algebraic problem here. This is applied to a real life scenario. So when we're stating our answer, we have to be very specific about what we're writing. Okay, now we're not done. We only have a value for y. We need to find a value for x. So we're going to take our value for y, we're going to substitute it into one of our equations and attempt to solve for x. So I'm going to take my value of y and I'm going to substitute that now into equation 1. Remember, you can use any equation you feel comfortable with. So I'm just substituting y is equal to 3 into equation 1. So wherever I see y, I'm going to replace it with 3. Now in this equation, I have 5x plus 12 times y, so 12 times 3. And that's equal to 61. Let's simplify, and then we're going to solve for x. So this would give me 5x plus 36 is equal to 61. And now to solve for x, I'm going to subtract 36 from both sides. So when we subtract 36 from both sides, I remain with 5x on the left And 61 take away 36 would leave me with 25. So to solve for x, we're going to divide both sides of our equation by 5. And this would leave me with x is equal to 5. So now that we have the solutions for x and y, remember you can validate your answer if you need to, if you feel as though you want to do that. But if you feel very confident in your ability that you have completed it without any bits of trouble and you think your answers are correct, you go right ahead to write your statement for your answer. And I'll just write it at the top here. So essentially when they ask us for the mass of one lollipop and the mass of one toffee, we need to remember, first of all, the mass of one lollipop is x grams. So when we're stating our answer, we're stating the value of x. And we don't need to write x is equal to 5. We can simply put that the mass of one lollipop is equal to 5 grams. And the mass of one toffee, that's the value for y, we just simply write that mass is 3 grams. Okay? Even if you had written x is equal to 5 grams and y is equal to 3 grams, all that is fine. But the important thing here, because we're applying it to a real life scenario, you want to make sure that your final answer reflects that much. So you show them that you understand what x and y represent by stating the mass, not just the numerical value, but stating the unit that goes along with it. So if you feel like this has been sufficient enough to help you approach worded problems in simultaneous equations with a little bit more confidence, feel free to give it a share and a like. And you can continue looking out for more videos. Remember, if you don't feel 100% above what you've just done in this lesson, you can go back over any of the things that you feel like you need to brush up on, and you can take your time, look back at this video a couple times, and when you feel like you've gotten it, I'm sure you will go ahead and approach all those worded problems and simultaneous equations, whether in your textbook or in past papers, with a little bit more confidence.